The dial indicator is a valuable tool that can be used for a variety of applications. One common application is measuring shaft alignment. The dial indicator uses a precisely geared mechanism that is driven by a plunger to measure in thousandths of an inch. In this video, we'll refer to thousandths of an inch as mils, sometimes referred to as thou. The plunger can move in and out. When the plunger is pushed in, the needle rotates clockwise, and the results are positive. When the plunger moves out, the dial rotates counterclockwise, and the results are negative. To show how this works in practice, we'll mount the bracket to the shaft of the movable machine, with the dial reading off the rim of the stationary machine at the 12 o'clock position. Make sure the plunger is midway between being fully extended and pushed in all the way, then zero the dial by rotating the bezel. In this video, we will only consider the vertical plane. Note, however, that the same principles apply in the horizontal plane. For our first illustration, we'll start with the shafts perfectly aligned. As we rotate the shafts, we can see that the dial indicator stays on 0 for the full revolution. Next, we'll lower all 4 feet of the movable machine by 20 mils to create minus 20 mils of vertical offset misalignment with 0 horizontal offset. Turning to view the misalignment axially, we can see the center points of the shafts 20 mils apart. Once again, the dial is set at 0 at 12 o'clock. As we rotate the shafts to 6 o'clock, we can see the needle moving in the negative direction because the dial's plunger is extending. When we get to 6 o'clock, the dial reads minus 40. This is total indicator reading, or TIR. We divide this number by 2 and rotate the bezel to minus 20 mils, the correct amount of misalignment. The dial indicator will now read the true position of the shafts, not just at 6 o'clock, but at any point in the rotation of the dial. As we rotate the shafts back to 12 o'clock, the dial will indicate 0 offset at 3 o'clock and plus 20 mils at 12 o'clock, which we know are the correct values.